All right, so this week we're going to take a look at really two main topics. We're going to look at what happens when you get a zero exponent or negative exponent, and also we're going to look at exponential growth. Okay, exponential growth, we're going to start to look at some pictures. Okay, but that won't be till tomorrow and Wednesday. Today, no drawing at all. Okay, just straight algebra. All right, so everything we've done so far, we've dealt with positive exponents. Okay, some of you may have done negative exponents in your other class, but what I want to try to do is look for a pattern. Okay, and we're going to try to figure out what anything to the zero power is, and then we're going to figure out how negative exponents work. Okay, who can tell me what 2 cubed is? 2 times 2 times 2. Oh, Alex?
8.
Yep. 2 to the third power is 8. Okay, now we're going to get a little smaller. What's 2 to the second power? 2 times 2. Yep, 4. How about 2 to the first power? 2. Right, now, does anybody know 2 to the zero power?
1.
1. Yeah. And if you weren't sure what it was, let's look at the pattern. What do you divide 8 by to get 4? Divide by 2. What did you divide 4 by to get 2? 2. So every time you're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. What's 2 divided by 2? Ben?
1.
1. So that's the pattern. Now let's go 2 to the negative 1. Let's continue the same pattern. What do you think 2 to the negative 1 would be? Okay, what did we do each time? Divide by? Yep, so just take the 1 before it and divide by 2. 1 divided by 2, yeah. 2 to the negative 1 is a half. Okay, do it again. What if you take a half and divide by 2? Someone said how much? Yeah, 1/4. So what do you notice about the kind of numbers that you get with negative exponents? Fractions. Okay, that's the whole key. Whenever you have negative exponents, it doesn't matter if the base is 2, 3. Negative exponents mean you get fractions or decimals. Yep. If you thought this was 0.5 and 0.25, that's the same thing. All right, but this one is always the same. It doesn't matter what number you raise to the zero power. Okay, I can do 9 to the 0, maybe. I can do 45 to the 0, well, 4 to the 0. 5 doesn't want to work today. So anything to the zero power is going to give me 1. Okay?
Any digit number, doesn't matter.
Right, so that's important.
So I'll give
So-
those no sounds, you have to write that.
Okay, so any non-zero number raised to the zero power is 1. Okay, I didn't show you this, but you could do negative 3 raised to the 0. And anytime we do a negative, what symbol do we always want to make sure we put? Yeah, I just had to add them in because I forgot them. Okay, you could even do a decimal. 5.7 to the 0 power. That's still 1. What's the only number you can't raise to the 0 power? 0. Okay. If you try to do this, strange things happen. Okay, you can do any number you want to the 0 power, except 0 to the 0. Watch what happens on my calculator if I try to do it. 0 to the 0. What does the calculator say? What kind of error does it give me? Yeah, it says it's a domain error. It means you can't do that. You can't raise 0 to the 0 power. That's the same error you would get if you tried to do something like this. Can you divide by 0 ever? No. If you try to divide by 0, it's a little different error, but the point is you can't do it. Okay? So that part that's underlined, make sure you write that on your notes. Any non-zero number raised to the 0 power is 1.
You guys have those first 4 words written on there, thus we can see.
Okay, this last part, okay, I just showed you, 0 to the 0 is undefined. It means if you type it in, you won't be able to do it.
Dave, you want them to write that 0 to the 0 is undefined?
Yeah, they should know that.
Okay.
Yeah. You can't raise 0 to the 0 power. Yeah. Okay, so what if I had something like this? 3 times 2 plus 6 minus 8 plus 7 divided by 5 times 2 plus 3 to the 0 power. 1. Exactly. You don't even need to do all that out. We just said anything to the 0 power, except 0 to the 0, is always 1. Okay. Does everybody have what's underlined? No.
Oh wait, so that whole thing inside the parentheses, you don't even have to work it out just because it's a 0 on the outside of the 1?
Yep, because it's raised to the 0. I checked the numerator real quick to make sure that wasn't 0, because if for some reason this whole top came out to 0, that would be a problem. But 3 times 2 is 6, plus 6 is 12. 12 minus 8 is 4, and 4 plus 7 is not 0.
Okay, so but in an actual test, you would want to have to work that out?
Nope, you wouldn't have to work it out. You just have to write it equals 1.
Okay.
Yep.
When is progress reports?
Friday.
This Friday?
Yep. All right, so let's take a look at a couple problems where 0 is an exponent. Okay, so the first one says 4 times x to the 0. Okay, forget about the 4 for a second. What's x to the 0? As long as this part is not 0, pretend it's anything other than 0, it's 1. Okay. This whole part right here becomes 1. And now we still have what's in front. What's 4 times 1? 4, yep. That's it. Okay, how about 5 to the 0? 5 to the first would be 5.
So just from 0? Or never mind.
Guys, remember you have to write these examples in, okay? They're not on your thing.
Okay,
You have space, but you have to write them in.
what did we say about anything to the 0 power? 1. Any number that you raise to the 0 power except 0 is 1. Okay? Okay, let's try this one. Example 1c. It says negative 3 times 2 to the 0. Okay, we're basically simplifying it. No letters in this one. Who can tell me what can I simplify first here? Do I do negative 3 times 2? Or do I do 2 to the 0? Yep. Remember, what's that word you can remember for your order of operations? Begins with a P, yep, PEMDAS. Okay. Always do exponents before you do your multiplication. All right, so Logan, what is 2 to the 0?
Can I tell you what it can want in the answers?
Just tell me that part first, and then I'll let you tell me the final part.
It's just 1.
Yep. 2 to the 0 is 1. Now go ahead, you got negative 3 times 1.
It's just negative.
Negative 3. Perfect. Okay, any question on how we got negative 3 there? Okay, we are going to get into some that have more letters, but and I know we did a couple, but for now we'll practice a couple more with just numbers. 3 squared plus 7 plus 8 to the 0. All right, so if I want to follow my order of operations, what's the first thing that I do here? Do what?
What do you add?
Adding? Not yet. What comes before addition in PEMDAS?
Oh,
Exponents. Parentheses first, but we don't have parentheses. So now exponents. Okay, start from left to right. Does anybody see something with an exponent I can simplify? 3 to the second? Sure.
So you 9.
Yep, it'd be 9. Okay, plus, for now, just leave the 7 because I still see some more exponents I need to do.
So it'd be 1.
Yep. 8 to the 0 is 1. And now just add these up. What's 9 plus 7? How much?
Would be 16 altogether.
Oh yeah, 16 plus 1 more is 17. Okay, good. Any questions on that one? Right. Right. Now we're going to start to take a look at where negative exponents can come up. Okay. When I showed you guys that pattern earlier, negative exponents always ended up being what kind of numbers?
So a lot of 6s.
Yeah. Negative exponents are always what kind of number? Fractions. Okay, so when you see negative exponents, fractions are going to come up a lot. Okay, so what I did is I wrote out here 6 squared divided by 6 to the 5th. Okay, we already know a shortcut to do this out. What's the shortcut without writing it all out? Yep, subtract the exponents. Larger minus smaller. What's 5 minus 2? 3. And we always put the answer where? Where the bigger exponent was. So that's why we had a 3 as the exponent, and it's in the bottom, because that's where the bigger exponent was. All right, so you guys already have this on your notes from Friday. So you subtract the exponents, bigger minus or larger minus smaller. You always put the answer where the larger exponent is. Okay, so you guys already know that. All right, so the reason we did it this way was to avoid negative exponents. Okay, this little trick of subtracting larger minus smaller and putting the answer where the larger exponent is helps you to avoid negative exponents. Okay, this is another way you can do it. Okay, did anybody learn to do it this way in their math enrichment class? Just do 2 minus 5, and 2 minus 5 gives you a negative 3?
Yeah.
You did it that way? Yep, this is correct. Okay, the answer that we had up above was 1 over 6 cubed. 1 over 6 cubed. The answer that you get in your other class, you might have done it with negative exponents. They're both correct. Okay, these are exactly the same thing. The only difference is one of them has what kind of exponent?
Negative.
And the other one has
Positive.
positive. Okay, our goal in this class is anytime we have a negative, we're going to turn it into a positive. And notice, to turn a negative exponent into a positive, what kind of number do I have here? A fraction. Okay, that's what's usually going to end up happening. Okay, fractions, either we're going to move things from top to bottom or bottom to top. Okay, it depends on the problem. All right, so this, what I just circled right here, kind of gives us a hint at how to get rid of negative exponents. Something to do with fractions. Okay. All right, so here is what you want to write down. Okay, let me see if that's fine. Okay, right below what this means. Okay, if you have a base with a negative exponent, and that's important, base with a negative exponent, those two things are stuck together. Okay, so if you had something like this, these come as a package deal. You can't separate that 2 and that negative 3. Those two things are stuck. Okay, so if you have a base with a negative exponent, you're going to move the base and the exponent that's with it. You can't just move the base by itself. Okay, those two things are stuck together. You're going to move the base with the exponent to the opposite place in the fraction. And what that's going to do is it's going to make the exponent positive. Okay? Now, in a fraction, there's two spots, right? There's the top and there's the bottom. So, if you have a negative exponent in the top, how are you going to make it positive? Little diagram right here. Move it from the top to the bottom. Let's say you already have a negative exponent and it's in the bottom. How are you going to make it positive? You're going to move it to the top. Okay? So all that this part is really going to involve is moving something from the top to the bottom, or the bottom to the top. Okay, let's look at the next thing we've got based on what I wrote right there. 2 to the negative third. Okay, 2 to the negative third, it's not a fraction. Okay, but we said when we deal with negative exponents, we're usually going to have fractions. What number can I put to make it a fraction? Yeah, the directions tell you right there. Put the entire expression over 1. Then you can move bases with negative exponents. Okay, that 2 and that negative 3 are stuck together. Okay. Where's my negative exponent in this fraction? Is it in the top or is it in the bottom? Oh, Victor? Is the negative exponent in the top or the bottom? Yeah, it's in the top. So where is that going to move to make it positive? Yeah, if it's in the top, it moves to the bottom. The 2 and the 3 move together. What did I do when I moved it? There's something here that disappeared. The negative, exactly. That's the whole point of moving it. It causes the negative to disappear. Okay? So once you move it, you don't keep the negative. The negative is gone. Okay, and all the rules that we learned last week, they still apply. Rules for adding exponents, subtracting, power to a power, multiplying exponents. That's all the same.
Did you want us to put like the bullet point underneath the lines?
I think as long as you know to put a 1 under a number, that's okay. Like if you don't have a fraction, you can always make it a fraction by putting it over 1. Right? As long as you know that, that's fine.
Guys, what if I have this? If I had that, negative 2 to the third. Huh? Do I have to move this? Do I have to move anything? Do I have to put this over 1 or anything like that? How come, Alex? Yeah, the exponent's not negative. I don't have to move anything here because the exponent's not negative. What if I have this? Do I have to move it? All right, what's it gonna become? Huh? No. The exponent will become positive, but the number will not. The base will not. So if you have a negative base and a negative exponent, the base doesn't change. It stays the same. The only thing that's going to change is going to be the exponent, going from negative to positive. So this would simplify to 1 over negative 4 to the third. And remember, if you're going to put that in your calculator, guys, like Mr. Hager always says, and he always reminds me, make sure you put parentheses around it. Because if you don't, you get the wrong answer. Does anybody remember from, I know it was a long time ago because we had, April vacation and everything. If I was to simplify that, negative 4 to the third power, is my answer going to be positive or negative? Anybody remember from last academic week? Is that you, Rose?
What?
You said negative?
No, that's Caitlin saying
Oh,
that.
you said negative, Caitlin? How come?
Well,
Remember the rule we talked about?
when you multiply it, then it becomes positive, but it by a negative.
Okay. Remember, we talked about if we have a negative base and an odd exponent, your answer is going to be negative, right? Because we have a negative base, but this number is odd. All right, so we'll have a negative. When we simplify it, it'll be negative. If I have a negative base and an even exponent, I'll get what? Positive answer. All right, I'm going to get a positive. All right, so just keep that in mind. Remember, you're not going to, when you switch it, if the base is negative, it stays negative. The only thing that changes is that exponent, nothing else.
That's really important, what Mr. Roy just showed, okay? Because I didn't mention that. That's the only exponent, that's the only negative that can change on the exponent. You can never change a negative in front. Really, really important point. Yeah.
Now this, what Mr. Hager was saying, as soon as I see, especially if because sometimes you'll get that line there already, you get that division line there already, right? You don't have to put it over 1. But this one, I see a negative exponent. The first thing I'm going to do is put it over 1. All right, the first thing I'm going to do is put it over 1. And what we mean is you're going to see these directions exactly written like this on your test. It'll say rewrite using positive exponents. You don't have to simplify. You don't have to do. We're not looking for you to do 3 to the 5th power. Those numbers are too big. All we want you to do is rewrite this expression with positive exponents. That's all we want. You don't have to do anything else. All right? So, anyone know, by raising their hand, what has to happen here? What's not good about this problem? What do we see there? That can't be there.
Negative exponent.
Negative exponent, right? On the top. Good, Logan. All right? So I'm going to draw my line. I'm going to put my 1 there. Actually, let me erase that now.
Logan, can you tell us what's stuck to that negative exponent?
E3.
The 3, good. Those
So what-
2 things are stuck.
What has to happen, Logan?
You put the 3 to the 8th power on the bottom, and you leave the 3 to the
Does the 8 become positive?
Yes.
Remember, we're moving it. Again, I see a negative exponent. I'm going to put the whole expression over 1. I took my Mr. Hager's doing, he's circling right now. I see, remember, like Mr. Hager said a couple times today already, that negative 8 is attached to the 3. Right? Take the base, put it on the bottom, make the exponent positive. That's all I'm doing. All right? So now this is taken care of. 3 to the negative 8. I took care of that. Alexis, what else is left? Okay. What do you think? Huh? Is it going to stay on the top? Yes? How come? You're correct. It's going to stay on the top. Why? Yeah. Is the exponent negative? No. The only time you're going to move it is when it has a negative exponent. All right. 3 to the 5th will stay on the top. Mr. Hager, you want them to take a step further?
Yeah. I was going to ask one thing, too, before you guys finish it up. What do you think would happen if you moved an exponent that was already positive to the bottom? It would become negative. We don't want to do that. If it's positive, leave it alone.
Now, we talked about this a little bit in the warm-up. We can take this one step further. All right? Because I have the same base on the top and the bottom. I'm dividing, right? But when I'm dividing exponents, what am I really doing? What am I doing to the little numbers? Say, Corey. Subtracting, right? What are you going to get when you do this, Corey?
1 over 3 to the 3rd.
Not perfect. 1 on the top over 3 to the 3rd on the bottom. All right? Corey subtracted these two numbers, 8 minus 5. Base stays the same. Base does not change. And he puts the answer where the bigger exponent was. All right? Remember, when the bases are the same and you're dividing, subtract the exponents. We did that last week, right? So all we did was take this one. We had the move stuff, and then we applied one of the rules that we talked about last week. So your final answer, I'm good because I have no negative exponents. All right, I'm fine. Mr. Hager, if they left it like this on the test, what would happen?
If the directions say to write with positive exponents, then this first step right here is fine. If it does say to simplify, then you're going to have to simplify to that last step.
And guys, even if it said rewrite using positive exponents, and you gave this as an answer, you'd still have it correct. You did more work than you actually needed to do. That's all. It'd still be correct. All right. Let's try the next one. All right. Somebody tell me. Gabe, what's the first? What do you see in this problem? Negative exponents. And we said in a couple slides before this, when you see a negative exponent, what's the first thing you should do? Doesn't involve any math. Anybody remember? What was the first thing we said to do if you see negative exponents? And it's a multiplication problem. Put it over 1. Good, Caitlin. All right? I'm going to put it over 1. Now remember, every number and variable with exponent is separate. All right? Which means the 4, the x squared, the y to the negative 2, the z to the negative 5. They're all separate. None of those things are attached. Right? They're all separate things. All right? Here's my line. The 4. Ryan Jadamons. Is that 4 going to stay on the top or go to the bottom?
Go to the bottom?
Is there a negative exponent?
No.
No, keep it on top. This is going to involve, this one, we're not even going to have to do any multiplication or subtraction or addition. All we're doing is just moving this stuff so we have no negative exponents. That's it. That's all we're doing. 4 stays. Ryan, what exponent is with that 4? Even though it's not written there. Huh?
X?
No. What exponent is written with 4 even though you don't see it? The 1, right? We could put it there. We don't have to. All right? It's 1. 1's positive. All right? Maria, x squared. Stay where it is or move?
I can stay
How come?
because positive, right?
The exponent's positive, yes. All right? Keep the base, the exponent stays. Good. Samantha, how about the y? Move it to the bottom, y. So what should I write on the bottom? Y to the 2, right? It becomes positive. Davin, think about what Samantha just did. All right? You got z to the negative 5. Stay on top, go to the bottom. How come? No. Gage, how come? Why am I going to move that z to the negative 5th? I agree. I'm going to put the z on the bottom. And what else? Careful. Kevin? Positive 5, why?
Because it's a negative.
Yeah, it's a negative on the top, right? By moving it to the bottom, that makes it positive. All right? So it'll be z to the positive 5. All right? If you see a negative exponent, you're going to move it to the opposite place. These are all on the top. So if I have negative ones, they have to move to the bottom. If they're positive, leave them. They don't need to change. Now, when I look at it, I got nothing on the top. I have no x's on the bottom. I have no y's on the top. I have no z's on the top. There's nothing else I can simplify. So all I had to do there was take and move stuff around to make it positive. That was it. So this is right here. My final answer. All right, for this stuff I did, that's a majority of the test, right? Just moving stuff around, making it positive. That's it. All right? Got another one like that coming up, I think. Everybody have this?
No.
No, okay. How's that? Good, Zach? Everybody got that? Got a couple more left. Now, we got this one. It's all over. We have 1 on the top and then negative exponents on the bottom. So that part's already taken care of for us. All right? So I'm going to put my equal sign. I'm going to draw my line. All right? Anybody see something there that needs to be moved? Kevin?
A to
So say it
the
again.
second power.
We got a to the negative 2, right? What are you going to do with it, Kevin? And do what?
Make it so positive.
Make the exponent positive, right? So it'll be a to the second. Justin, anything else that you have a problem with?
It's b to the negative 3.
What are you going to do?
You make 3 positive.
Yeah, and? Think about what Kevin just did. How do I make that 3 positive? Where do I put it? It's on the bottom now, right? How am I going to make it positive?
On top.
Over to the top. So what should I write on the top, Justin?
B to the 3rd power.
Good man, right? It's positive, right? So I took care of this. I took care of this. Anything else there that hasn't been taken care of yet? 7. Stay or go? Stay where? Bottom. Perfect. If you wanted to write 1 on the top, you could. You don't have to, right? 1's just kind of there, taking up space. If you write something, if you put something like a variable with an exponent where the 1 was, you don't have to write it. But if you did, it wouldn't be wrong. You still get it right. All right. So that one was a little bit different because that was the first time that we had negative exponents on the bottom. All right. Good. Last one. Hopefully. There we go. All right. Good. Same thing we've been doing, right? We're going to put it all over 1. Okay? I'm going to draw my line. For some of them, like the last one we did, the division line was already there for us. If it's not there, right, and it's like it's a expression like this, put it over 1. Okay? Chloe, do you see any problems there? Anything that needs to be moved? What do we have to move? Negative exponents. Do you see a base with a negative exponent in that expression?
Yeah.
What is it? D to the negative 5. So what needs to happen to it? It's negative on the top, right? How would I make it positive? Move it where? If it's negative on the top, I'm going to move it to its opposite place, right? So what would the opposite place be? The bottom, right? What am I going to write on the bottom? Careful. D to the 5th, right? When you move it from the top to the bottom, that's what makes it positive. All right? So D to the 5th. All right, so that's taken care of. Alexis, what am I going to write on the top? Yeah, because remember, we talked about this. There's an exponent of 1 with that 6. We just don't write it every time. All right? So it'll be 6, then it'll be C to the 2nd. Final answer. Again, I have nothing that's the same on the top and the bottom. Right? No bases that are the same, so I can't add exponents and I can't subtract exponents. Zach, question? Or just stretching?
Can you go back up to 2A?
2A? Sure. Everybody's good with this? Mr. Hager?
Put that 1 on the bottom.
Oh, like we said before, guys, if you want to write the 1 with the D to the 5th, you can. If you don't write it, you're not wrong. Right? You can do it either way. You can put the 1 there. You don't have to put the 1. Doesn't matter. All right. Does everybody have this? Everybody good? Zach asked if we could go back up. 2A, you said, Zach? Mr. Hager's going back up. So we got two more. We got two more left, and then the rest. Just talk about what the homework is, and then you have 4 you can do on your own.
Homework.
Zach, you good with 2A?
Yeah.
Or whoever, yeah. All right, last two. Okay, this is kind of a special case where you have a fraction raised to a negative power. Okay, we're going to see a pattern that happens here. Okay, I want to show you guys something like this first. Does anybody remember how you do something like that? What do you do with this 2? Yeah, it's almost like you distribute it to each exponent. What are the exponents that are here if I didn't write them? They're 1s and 1s. Okay? So if you did this out, what's 1 times 2? 2? And what's 1 times 2 again? There's a 1 right there. And that's how you do it up. Okay? With division, it's really the same thing. Okay? We're going to distribute that -4 to each exponent. What's the exponent in the top?
Even though it's not written there.
Yep. 1. What's the exponent in the bottom? 1. So now let's do it out just like we would do it if it was multiplication in the parentheses, even though this is division. So I'm going to have 2 to what power on top? Yep. -4 times the 1 gives me -4. And how about on the bottom? 3 to the -4. Okay, any questions on how Caitlin did that? She just multiplied the -4 to each exponent. Same rule we learned last week. Okay, now is there anything that is wrong with that fraction? Anything we don't like? Yeah, where is there a negative exponent? Where, Sabrina? Yeah, there's a negative exponent in the top. So we're going to deal with that. And in the bottom.
Oh, if they're both negative, so you just switch them places?
Yeah, they're going to switch places. Okay, the one that's in the top is going to move to the bottom. And the one that's in the bottom is going to move to the top. Okay, so Ariana, when I rewrite this fraction, what's going to be in the top now? Perfect. 3. And she made the 4 positive because we moved it to the top. And Sam, can you tell me what's going to be in the bottom? 2 to the 4. Perfect. So what really happened here? If you wanted just to describe the pattern. Yeah, really, it just flips. What the 3 and the 2 switch places. And that's your answer. Okay? Now, when you did your MCAS class, did you guys go any further than this, or did you stop there? Like, did you see something like this ever? Because this is also correct. You stop there? Okay. These are exactly the same thing, but if you want to stop there, that's fine. All right, so let's try, one more, yeah. Let's try this one. Okay, do you guys want to go through it step by step, or do you think you can just tell me what the final answer would be? Sure. Gage, what do you think? Do you want to go through it step by step, or just jump right to the final answer? Final answer? You think you can tell me?
Not really, but I'll try.
All right, give it a shot. What's going to be on top?
Wouldn't it be 5?
The 5 is going to go on top,
Yeah.
and what's, because you got to flip it, and what's the exponent on the 5 going to be?
Positive 3?
Yep, because we flipped it. Makes the exponent positive.
And then it wouldn't be -1, would it?
That negative and that 1, that's going to stay.
Okay.
The only negative you can get rid of is the one on the
So
outside.
just need to be -1 to the positive 3.
Yep, and what do I want to make sure I put around the negative 1?
That's parentheses.
Perfect. That's exactly it. So he did it perfect. He flipped the bases and made them +3 for the exponents. Perfect. Now, if they did say to simplify, let's, because we didn't simplify the last one, let's just practice simplifying this one. What's 5 times 5 times 5? 125. And what's -1 times -1 times -1? -1. And what do you get if you do 125 divided by -1? -125. Good. Okay, so if they ask you to simplify, that's what you'd need to do. If they just said rewrite with positive exponents, you would have been good at that first step I circled. Okay, any question on that one? Okay, so I just took a look at your test. I think there's about 16 questions. We just covered the first 9 to 10. Okay, there's about 6 or 7 more questions we're going to learn Tuesday and Wednesday.
Nice.
All right, so a couple reminders before we give you homework. Okay, 4th quarter progress reports close Friday. Okay, Thursday.
Don't pack up, you're still gonna need those note sheets.
Okay, Thursday, MCAS review day. Well, MCAS and a review day. And then our second to last test for the term on Friday. Okay, homework tonight will be a worksheet on 6.4.